Everyone, welcome back to the workshop. Today we are taking a look at the Genmitsu 3020 Pro Ultra. This is their latest version of this style machine. It is fairly compact, but packs a lot of punch in its rigidity and a pretty stout 700 watt spindle. So you're gonna be able to push this thing faster and use some bigger bits than you might in a lot of other small form factor machines. So I'm gonna put it through some tests on a variety of material. We're gonna look at the build. I'll give you kind of my rundown of how it worked in my small workshop here and maybe help you figure out if this is something that's gonna work in your workshop too. So if you wanna find out more, stay tuned. I'm gonna jump right into it. So we have looked at a number of Sainsmart machines over the past year or two in the workshop, and so far they've all been pretty well. This one's probably the smallest one we've looked at, and so we're gonna jump into that today. Now, Sainsmart did send this out to me for review, free of charge, but they're not paying me, and they don't get to see this beforehand. So I'm giving you as best of my real world experience with this machine, my thoughts, my experiences as I can. And so with all that information, just keep that in mind. But this is a fairly compact machine. The shipping box wasn't too big, but it was fairly heavy. And we did get it unboxed, and I'm not going to go through the whole build. I might overlay some of it. They do have a nice manual for the build, and really there's kind of three main steps to get the assembly done, and then a few more cables you have to hook up. But their manual does do a pretty good job of illustrating and documenting those steps to get you through this. But primarily you got to put the rubber feet on the bottom of the base, the whole kind of lower assembly. Then you're going to attach the gantry. There are 8 screws on each side, so you might want to just block it up a little bit, get those screws kind of started. Don't tighten the first ones down until you get them kind of all lined in. It'll settle kind of into place, and then you can go through and tighten everything down. And after that, then you do need to put the spindle holder on and then slide the 710 watt spindle that they include in. After that, it's just hooking up a few wires and cables and you're kind of ready to go. So the assembly on it's fairly minimal. However, I do recommend that you go through and just double check all the other screws. Make sure nothing has come loose. You don't want to over tighten them, but just make sure that they're not loose and going to cause you some vibrations to come out. But the assembly is very simple, very straightforward, and pretty easy to do in about maybe 15 to 20 minutes tops. All right, let's talk a little quick about the specifications of this machine. It is pretty much an all metal assembly. There are a few plastic parts as far as the cable chain and maybe a few spacers, but as far as all the important parts, the rails, the gantry and whatnot, it is all metal. It's a very stout machine. Now with that, it does have a working area of 300 millimeters by 205 millimeters and 78 millimeters in the Z-axis, or roughly 11.8 inches, 8 inches deep and 3 inches of Z-axis movement. The X-axis rides on linear rails, while the Y-axis and Z-axis have linear rods. They're, I believe, 12 millimeter and 10 millimeter, respectively, on the Y and the Z-axis. And then they have T8 trapezoidal lead screws, providing the actual movement, connected to some 60 millimeter NEMA 17 stepper motors with 7.3 Newton meters of torque. So they're kind of a higher torque stepper than their previous models. Should give you a lot better rigidity and holding power when going through things like metal and such. So now they do include their the Genmitsu, they're calling it a trimmer router spindle. This is kind of a typical trim router, but it's about 710 watts of power. It does have a 6-speed dial going from about 6,500 RPM on up to 30,000 RPM on that dial. And then it does have an ER11 collet at the bottom, which is really nice. It allows you to swap out to different size bits. So it comes with an 1/8 inch collet. I also picked up a 1/4 inch for my tests, but that's not included. You just get the 1/8 inch one by base, but there's a lot of places where you can pick up those collets. They're very universal. So some other features of this CNC machine, we do have e-stop button on the right side of the gantry here, so it's fairly accessible. They do have limit switches on both ends of each axis, so it's going to allow for accurate homing as well as overrun protection off of the other side of the machine. So it's not going to tear itself apart when it hits those limit switches. It's going to stop its movement. On the back side, we do have the control box. It's fairly well encased. There is a heat sink here with a small fan on there to help with cooling. You do have your various wires that are already plugged into it to do all your control. The only one that you will likely have to plug in is your power, your USB, and then as well as the Z probe, unless you maybe get some of the other options, and there are additional plugs in here for that. But the base model really primarily just power, USB, and if you're going to use a Z probe. You see also on here, they do have the nice cable chain, which everything's pre-routed in there to there. The router power does unplug up there, so when you put it in, it's easily disconnected if you need to take that out and service it. Now, I did mention it has USB connector on that control box, so that can go directly into a PC using CH340 drivers. You can connect it to any GRBL-based control software. I personally like to use G-Sender, but there are a number of other ones out there. However, they do also offer an offline controller with this. And this is wired into that control box on back. You can then use a micro SD card to load your files, and then you can do all of your operations without a PC hooked up to it. However, I prefer to use a computer hooked up to it. I have my laptop running it, so all my tests were done running directly off the software, directly connected to a computer. So the final thing is they do have a spoil board here. It does have 6mm threaded holes in there for some supplied clamps, or you can use your own. So it's a nice solid flat surface there. They do have an optional MDF spoil board, so if you're doing a lot of cut through operations, you may want to consider using that as well. So the other thing I will point out that hasn't been on all the models is they do have these knurled knobs that are connected to the lead screws and the steppers, so you can kind of make fine-tune adjustments on setting up your home point. You would basically just kind of dial that in a little bit and then go into your software and hit home before starting your job. So there are a number of optional accessories for this CNC machine. Probably the important one you should get is the dust shoe. They do make a dust shoe that fits around the spindle. It does have an insert in case you have the 69mm option, but this is really critical. With any CNC machine, you do have to worry about dust control. I didn't use it in all the tests, so you could kind of see the operations going, but whenever possible, you want to use this to help keep the maintenance of the machine down. It'll keep the dust from getting on the rails and the threaded rods and such, as well as just keeping the particulate and such controlled, and so you're not breathing it in and having to clean up more. So this is definitely one I would look at. Again, it's an optional add-on. This is a 3D printed piece that I had to add to hook it up to my shop vac. But take a look at this. They have their options, or look at a similar one. A couple other ones that you may want to consider is there is a power relay for the spindle that you could also hook up your dust extraction to. So by default, you have to manually turn the spindle or the router on or off. Something that is possible to forget when you start a job. So if you're not using that relay, this should be your first thing you turn on is your spindle, and then hit your start on your job. But if you add that relay to it, it will automatically turn that on, and it has a secondary port that you could also have your dust extraction system turn on with that as well. So another nice creature comfort added feature, not required, but does make some things easier and less likely to forget to turn that spindle on. The other one down the road is after you get this and maybe you want a little more length, they do have an extension kit. It does make it a little bit deeper in the Y-axis, so it takes it from a 30-20 to a 30-40. So basically doubling your width from 20 or 205mm to 400mm. So it will add a little bit of working area for you just by replacing a few rails and such on there. So another thing to consider. They also have a number of different accessories for like laser modules and such. They're all on their website, and I'll have links down below where you can check those out as well. Now, as typical with Sainsmart and Genmitsu, they do include some initial clamps. So this has that 6mm threaded rod in there, a knob, and then kind of an aluminum bar here, and then a spring. So these can thread down into these threaded holes in the panel. And they'll work, but the thing I don't like about them is they do stick up kind of high, and they're metal, and if you don't get your pathing right, or you don't quite home it right, or just forget at how high these are, the spindle, the dust boot, things like that can run into these. And so I prefer to use something a little more low profile. I went ahead and 3D printed out some clamps of my own here, and they just have a 6mm threaded screw. They have just a small little lip there and then a little adjustable area. And these worked pretty well for most things. The spacing on these kind of limited my function, and these would probably need a little reworking, some more adjustability. So they are an option. And then I also used a lot of time just good old, this is kind of a light duty double-sided tape. And so as long as everything's flat and you got a flat surface on the other side, this will do the majority of the holding power. Sometimes you just need to follow up with a couple of these to properly hold it in place. So Another option is using painter's tape with CA glue and such, as similar to double-sided tape. Number of ways to hold your material down, but the one thing I kind of shy away from is these bigger, heavier metal clamps, because you can run into that with your spindle. You're probably going to damage this, you're probably going to break your end mill, and you could possibly torque the whole spindle a little bit. And so just from a safety aspect, I like using something a little low profile and a little bit more, if you accidentally run your end mill through it, no big deal. It's going to cut through this and not be the end of the day. It could hit the metal screw, but a lot lower profile and less likely to do damage. So it's just one of the things I'd like to see maybe changed, is offer some more plastic style clamp options in these. As far as end mills, they do provide you a set of these 20 or 30 degree kind of basically engraving bits. They're just kind of a V bit, and those will be good to play around with, just be able to do a little bit of kind of marking. But with this machine and this spindle, you're going to want to be able to do a little bit more. So for my tests on this machine, I used one of my favorite manufacturers for end mills, and that's a lot of the Jenny bits from Cadence Manufacturing. My friend Cody there has been making these bits for makers, for machines like this. So these are, we're going to go through and use a number of these. It's a mixture of 1/8 inch and 1/4 inch end mills. And so I'll try to point that out on each project, what I used. But the cool thing is you'll hopefully find out in the projects, is I was running these at the full speeds that I would say over on my bigger Onefinity machine, and still having good results with it. So this might be small in size, but it definitely is stout and was able to drive these bits at the speeds they want to run at. All right, let's take a look at some of the projects I was able to complete with this machine. Started out with this 3/8 inch piece of plywood, just a scrap piece I had, and did a simple carve. So with this one, I'm using the 1/8 inch mini Jenny, and ran that at a 1/8 inch depth of cut. We did a single pass to cut all this out, running it at 100 inches per minute, a 40% step over to do basically the pocketing out of this text. And I was running this at the dial setting of 3, which is about 14,000 RPM, give or take. And so it came out pretty well. Everything was fairly clean. I didn't have to do a whole lot of touch up on that. There are just a little bit of fuzziness on the inside, so possibly just could have done a final profile pass on the outsides to really clean that up. But other than that, everything looks good. There's not a lot of like witness marks on the inside, so it looks like out of the box, maybe tramming's okay. And this job took about 2 minutes 33 seconds. This is roughly about 5 inches by 3 inches tall as far as the cutout, and just a kind of a simple test to get a feel for how the machine's doing. Stepping up from there, did another engrave, this time using a 60-degree V-bit. Now this is a 3-flute down shear bit that Cody makes, so it tends to drive the fibers down instead of pulling them up. And again, getting a pretty clean cut on this. Ran this with a pass depth of 0.1 inch. So there's a couple of layers to it, and there are some slight lines where you see that. So possibly doing this at more of a full depth cut would work out. I don't feel like this was strained on the machine, but we were running at 60 inches per minute. And again, at about that dial speed of 3, right around 14,000 RPM. Now this one did take a little bit longer, took 9 minutes to complete this. This is roughly, I think it was about 9 inches wide. Going through, but getting some pretty decent detail, getting into the fine corners on all that, and working out pretty well. Next up, tried out doing this maple catch-all tray. So this is about 5 inches by 4 inches, 5 inches wide, 4 inches tall. And this is one of my favorite bits from Cody. This is a 1/2 inch bowl cut bit. And so this does put a lot of strain on the machine, or it can, as it's kind of digging in that first pass. But again, we went with the recommended settings. Did 100 inches per minute, 0.1 inch depth of cut. We ramped them in at 60 inches per minute and a 1/2 inch length, just to kind of give it a little ease into there. And other than the very first cut into each layer, it was very clean, very quiet. I think I could have actually sped this up a little bit. Now there are just some slight lines showing up. I don't know if those will appear on there. You don't really feel them too much. So we could increase or decrease our step over to maybe get rid of those. I could possibly just see if there is any sort of tramming involved with this, but this would also very easily sand out. And it's something you're gonna get just slight witness markings. That's why I usually do these with the grain, so they're not as visible. Did do a profile pass on the last cut of each layer, and that left a really nice interior cut. And then on the outside, I switched out to the normal 1/4 inch Jenny to do the outside profile cut. We did that at 100 inches per minute. 12,000 RPM on the dial, and did a 1/8 inch depth of cut on that. So the pocket took about 17 minutes to do, and the profile cut about 2 minutes to do. So just under 20 minutes for this tray, and came out pretty nice. So after doing that tray, wanted to see about some tight cutting and through cuts, and went ahead and cut this out. This is out of some 1/2 inch plywood, just kind of a SVG file of a gear. And we ran this with, again, the 1/8 inch mini Jenny, ran it at 100 inches per minute and 1/8 inch depth pass cut, and did this in about 4 minutes, just over 4 minutes. Came out fairly well. There's just a little bit of fraying on some of the edges, and that's going to be probably more of this plywood. Anytime you have those veneers, they tend to give you a little bit more of that issue than solid wood. But did have a few tabs on there to help cut this in place. But overall, did work pretty well. I'm pretty happy with that. The dimensions came out okay. I probably should have cut a second one to see how they might mesh as far as the precision. But so far, everything's been measuring out pretty much spot on within a couple hundredths as far as the parts fit. So I'm pretty happy with that, and the finished look on all this, doing pretty well. So the next project, wanted to try something with a little more detail, and these are some of the 3D relief images I like to do. This one is a light bulb going off, and it's kind of dished out, as you can see here. So we started out with an 1/8 inch Jenny bit, just kind of doing the rough passing, clearing out as much of this as possible with leaving about a 100th difference between there. And then come back with the tapered ball nose. So this is a 16th inch tapered ball nose, the skinny Jenny from Cody again. And this does the nice detail work on this. So with this one, I was doing a 16 tapered ball nose, 85 inches per minute, and an 8.3% step over. So did take some time. The roughing pass took just under 20 minutes to get through. And then the finishing pass took just under an hour. So you're talking about an hour and 20 to do this whole job, plus the time to do the bit change. But I did just some minor sanding after this. I think on the video I can show you the rough sanding. And then I just ran it with the dust mop on the drill press to kind of clean up any of the fuzzies. But that did come out very nice. This isn't finished with anything. This is just kind of off the mill, and then with some light sanding. And so it does do some nice detailed work. And the resolution on that is getting rid of, there weren't a lot of like the lines with that small step over either. So you can do more than just wood with this. You can do some acrylic. So ran some tests on some clear acrylic to kind of get a feel for it. And I'm doing this with an O-flute bit. This is an 1/8 inch O-flute bit that Cody is going to be bringing out pretty soon. He's got his 1/4 inch out on the site, and hopefully soon he'll have the 1/8 inch as well. But went ahead and did the profile cutting. I needed to figure that out, going at a 16th inch depth of cut and 60 inches per minute, 10K RPM on the spindle. Played around with both conventional and climb milling. I did get a slightly better edge on conventional milling, and so did that for all the cutouts. But I had some scrap of the laser safety acrylic, so went ahead and used a 30-degree Groovy Jenny bit. Went just down, just wanted to scratch the surface with this. Went 60 inches per minute, 10K RPM, and did a very fine step over to do the engrave. Now the engrave took about 10 minutes, and then we did the cutout, which took about 30 seconds. And so did a pretty nice job on that. I think I'd like to do the taper ball nose for the engraving. However, on some of the fine detail for this, my logo has that stitching in it. That's why I went with the finer point Groovy Jenny. Doing some engraving on acrylic is kind of you got to play with each style. This laser safe acrylic, I'm not sure if it actually might be a polycarbonate or not. But I had some scraps, so I thought I'd throw it in there and play with it. So this machine is rigid and has the power in that spindle to be able to work with some non-ferrous metal. So had a sheet of aluminum and did some testing. Again, we're using this O-flute bit, and if you can see it here, this is one of the prototype bits, but it's a single flute, 1/8 inch bit, and it's an upcut to help clear the chips out of the way. But that's the style you want to use with both acrylic and these non-ferrous metals. And you do also want to try to add a little bit of cooling. I was using some compressed air when making these cuts. And ignore this first pocket, that's from an earlier machine, but started out with just a simple 1/2 inch pocket there and was able to mill that out without too much hassle. Running that at 30 inches per minute and a 30-second depth of cut. So 0.03125, I think it was. Ran the spindle at 16,000 RPM, so closer to the number 4 on there. And did do that pocket pretty well. So I wanted to play around with something that might be a little more realistic off that sheet. And so just envision if this was maybe like a miniature side gantry for a CNC or a laser, and did a few operations. So we did a pocket there at a 1/16 inch depth, as well as we made some kind of recessed screw holes there, both kind of pocketing out for the head, but also the through cut there. And then the edge profile cut we did as well. So this whole part took 5 minutes to do all those operations. They all were pretty smooth. I think what I should have done though is maybe just do a final pass on that edge. I don't know if it's coming through on the video, but I'll try to throw up some photos. It's just a little bit of chatter on that edge. And I think if I would have just come back with one more final pass, maybe bring it in like 1,000th or so, it would have probably just cleaned that up really nice after doing the bulk of the cutting. But overall, very happy with how the pockets went on there. They're very smooth and shiny there. Actually, the edges in there are pretty good as well. Everything was doing it in pretty precision. I measured these out and they were coming out spot on. And so, you know, for 5 minutes for this small, like 2 by 3 inch part with some holes and some pockets, not too bad. Again, I wasn't using any fluid. I was just using some compressed air to kind of blow the chips away and help cool the bit. And the bit did pretty well. So I'm going to continue to work on that a little bit with Cody and try to dial in some speeds for that 1/8 inch bit. Using that one because of the smaller size on here. Of course, he does have his 1/4 inch bit, which will allow you to pick that speed up and maybe go a little bit deeper on the passes as well. But this machine can work with some metals, your aluminums and your brass. I don't know about, you know, necessarily steel and such. It might be possible, but you're going to really have to work on your cooling. You're going to really have to play with your speeds and watch for that chatter. But definitely in things like aluminum and brass, it's definitely a possibility. So those were all the tests I have run so far with this machine. Did all of them quite well, and I was very impressed that it was able to perform with those bits at the kind of the specs I would run more on my larger machines. So the rigidity and the spindle power is all making this a fairly robust, compact machine. Its only downfall is your limited workspace, but if you have a smaller shop, if you have something that maybe you need to be able to set this on the bench and move it out of the way, this is going to be a possibility. I will caution you though, if you're not going to put this in any sort of like enclosure, even partial enclosure, you're definitely going to want to get that dust shoe. So check those accessories if you're looking at this. That would be absolute minimum. I would also look at that spoil board. The clamps are something I probably would replace, not use the stock ones as well. I did some 3D printed ones. I think I'd still need to tweak some out, but if you want to see some others, check out my friend David over at the Clack Shack. He also did a review on this machine and he had scaled down some other clamps as well. Hopefully this is a nice overview for you on what this machine can do. I think for a small shop, this is a nice way to get started. It's not going to limit you in speed. Your limitation's going to be this size. So for the price, for the type of the spindle that's on there, you got the ER11 collet you could swap out for different size end mills and such. You got some nice flexibility. Really, the biggest thing there is, can you deal with the smaller size? If so, I think this is something you might want to consider at that price point, and jump in and have some fun doing some CNC machining. So thanks again for watching this, and thanks again to Sainsmart for sending this out. I hope I gave you a decent overview of this machine and some of its capabilities. If you do have some questions about that, go ahead and leave those down below. Let me know what you thought of this review or that machine, and I'd love to have that conversation going. If you are interested in this machine, I will have links down below where you can find it. They are affiliate links, so I do get a small commission that helps me buy, you know, sheets of aluminum acrylic to do some of these tests, and that just helps me produce more content like this. But as always, I'm first and foremost just giving you some good information on this machine. If you do have any questions, go ahead and leave those down below. Hit that like button on your way out, and if you're new here, hey, consider throwing me that subscription, and you'll get to see more of this, more project videos, more laser stuff. That's the kind of things I do out in my workshop here. So thanks again for hanging out with me, and we will catch you next time. But I hope you get on your workshop and make something too. We'll see you soon.